Thank you all for coming. Thank you, Mike, for coming. So we'll talk about CoreWeave. We'll talk a little bit about AI. We'll talk about climate and energy. But I want to start by asking you to tell us a little bit about your company. You've built a company that now has positioned itself as sort of a huge provider of AI infrastructure, competing with some of these hyperscalers, as we call it. You're the new kid on the block that now is like a huge company in its own right. You can tell us a little bit about that journey?
Sure. First of all, Bruce, thank you for the introduction. That was great. As Bruce said, I've known Bruce for a long time. We've spent a lot of time in the early days of our careers kind of working through some really complicated and interesting and I would argue really important questions around climate change. It has been truly my privilege, and I think of it as a privilege to have spent and will continue to spend my career working on what I believe to be the two issues of our time, which is climate change and artificial intelligence. I think they're seismic in nature and have the ability to really bend the trajectory of the world. And so it has been a privilege to work on these two things. And I feel very fortunate that I've managed to put myself, with the help of an amazing, amazing group of people, in a position to work at a company and to build a company like CoreWeave that has done some truly unbelievable things. It's been a lot of fun. And I'll talk a little bit about the company now. So CoreWeave, the way we think about it is it's the AI hyperscaler. It's the force multiplier for people working on artificial intelligence. And what we have built is the first AI native cloud. And when we started the company, we really started the company in crypto. We were running a Hudson Ridge Asset Management, which was a hedge fund that was a systematic, algorithmic, fundamentally driven natural gas fund, right? So basically all those big words mean is we were scraping the internet for big data around natural gas flows in the US pipe system and looking at consumption and weather patterns to drive signals for buy and sell. And so that's a little bit of the tech piece of it. But when you build an algorithmic system, one of the things that happens is you build it and then it's built. And you kind of run it and test new things and watch how it works and make sure it doesn't blow up the world and that kind of stuff, right? And you're basically monitoring the system, and which gives you a lot of time to think about other things. And we started to think about crypto, and crypto's fascinating, right? It's just like a fascinating concept. We're curious and nerdy and all those kind of things. And so we got interested in crypto and then got interested in the security layer in particular, and then started to play around with it. We looked at Bitcoin and thought it was a terrible idea. From a security layer perspective, because at the end of the day, there was some brilliant engineer in China that had built the ASIC machine, and I just assumed they built it. They're probably better at running it than I am, and so I didn't really see that I brought a lot to the table there. But the GPUs, those were really interesting because GPUs you can do a lot of different things with, and we knew that from the start. And the way the lens that I look at the world with really was built in the early days, kind of growing up with Bruce and Jack and all these other guys that focused on this stuff. But like my lens was incredibly quantitative in nature and like hyper rational and focused on the concept of optionality and flexibility, right? Like that's the key things that I look for when I am kind of exploring things, because I just think that that's flexibility is where things get interesting. And so, the GPU had all of this ability to kind of reorient itself. And we had no idea what we were doing when we started the business. That was the beginning of Atlantic Crypto, which ultimately became CoreWeave that everybody knows. What the mission of the company is to kind of rethink the way that the cloud needs to work for a new generation of computing, right? Like it stands to reason that when, three of you will come out of this auditorium, hook up, build a company, and become the third largest consumer of computational power in the world in 6 months, that the requirements of the cloud need to be different, right? And the cloud went through this very, very fundamental change that people to varying degrees understand or don't, which was moving from sequential computing to parallelized computing. And it was kind of the genesis of what we went about building, right? We built a company that does three things, right? And the first one was to build a company that had a beautiful, elegant, technical solution to a problem. And that problem was, how do you serve compute to the world that is going to require size and scale of parallelized computing that sort of defies human imagination, right? And so that was the first piece of it. And what we did, it's very hard to say that you have an advantage over Amazon, Microsoft, and Google, right? And there is an audacity, a hubris, insanity perhaps, of trying to take on that part of the market. But be that as it may,
but you did.
But we did, and we did, and I don't like. Once again, we think about it's like myself and Brian and Brandon. It's just everything is about like risk and exposure, and so like you had the confluence of this new type of cloud computing with this new world-changing technology that required an entirely different approach to infrastructure and an entirely different approach to finance. And it was only because of the confluence of those 3 or 4 different enormous, each one of those enormous moving pieces happening simultaneously that allowed for the dislocation that occurred. Like it couldn't be done otherwise. And we saw that, right? Like we saw the abject dominance of the hyperscalers within the cloud space through the CPU era, right? Like, and there's reasons for that, right? Like once they are able to achieve a systemically lower cost of capital, we have seen those cloud computing giants crush competition based on that one sole advantage. It has nothing to do with the quality. But that only works in a world that moves incrementally. In a world that moves in step functions, that advantage doesn't hold, right? And if we think about it through history, there's all these times where things just change, and when things change in a large enough way, there is the opportunity for disruption. And so we went from sequential computing, think of that as the cloud that supports data lakes, and it supports websites, and your mom keeps her photos on it, and all that kind of stuff, right? And it is a beautiful, fantastic solution to that problem. But when you move from that environment to parallelized computing, you've changed some of the fundamental assumptions in what the cloud has to do and how it does it. And it turns out that the things that made the legacy cloud great at what it did actually are negatives in serving the new type of computing, right? The hypervisor, which is the piece of software that just does this incredible job of the last mile of computing, right? Like if something breaks when you're using a CPU-based cloud, you never know it, right? Because it just goes out and grabs a new virtually just grabs a new CPU, slaps it in there, and you would never even know that anything broke. But that doesn't work in the parallelized world.
Can I stop you for a second? Because I think it would be interesting for you to visualize for the crowd. When you build out a new data center that in some sense can be configured to work as one computer.
Yep.
Tell this crowd, how big is that computer? In physical size, in needs, because these things that, I've seen some of them, they're daunting.
Yeah.
And you actually specialize in that field.
Yeah.
So tell us a little bit about it.
So like, it's like the Death Star, right?
But in a good way.
Yeah, yeah. I'm sort of joking and sort of not, right? Like initially it was a single Death Star, and now what's happening is what we're working on is, when I say we, I mean the entire space is configuring so that you can bring in multiple facilities of this enormous scale and have them work in concert. And so, it started out with a cluster of a few thousand GPUs, and think of that as a couple computing racks, whatever. And then it turned into football fields, and then it turned into multiple football fields. And it's just like, it is wild. It is just, it is really amazing, the scale of these things.
And I think what's important for the audience to understand is that when what Mike is describing is a football field or 4 football fields that are connected when they're actually working, so that from the point of view of the user, they're one computer. Okay, so you have sort of hundreds of thousands of GPUs that are themselves parallelized machines. So they're doing, hundreds of thousands of parallel calculations, each of them simultaneously, and they're all working on the same problem simultaneously.
Yeah.
And that is an incredible, and in some sense, to go back to your crypto origins, crypto mining was in some sense a GPU exercise, because it was, so you found yourself, I'm imagining right now, but you found yourself with a much more pure play infrastructure that was GPU based, rather than the hyperscalers that they may have had 10% GPUs, 90% CPUs, and data server racks that we used to sort of rent out to do compute, but different type of compute back in the day. But you mentioned that you had, as a result, different architecture in your data center. That then when you took your data center and you made it 10, 100, 1,000 times bigger, that architecture was actually much more efficient for the pure play AI.
Yeah, the software that we built, that solution allows you to understand what's going on in this computer that takes up multiple football fields in a way that the hyperscalers just couldn't, right? You'd have a problem with hyperscalers and you'd have to send them a what just happened, and 2 weeks later they'd come back with it. Whereas the way that we built it, you would get real-time feedback to your dashboard and know what broke or why it broke, or if it was going to break, can we cordon it off before it breaks? And the problem with it is when you run a data center as a computer, as an AI factory, as Jensen will speak to it. The problem is when one GPU breaks or one connection flaps, the entire data center goes down. And as you guys have all been watching, the numbers, the cost of these things is just kind of astronomical. And so losing an hour on one of these machines is losing an hour on a $40 billion piece of machinery. That's expensive.
Do you think that this sort of moat that you had initially is a defensible moat when you think about the next 3 to 5 years and the hyperscalers and what they're doing?
So I think of the moat, as I think of most things in this space, is it evolves, right? And so when we're launching the company, the moat is we have a better piece of cloud. And I believe fundamentally that all of the neo clouds and all of the hyperscalers will ultimately wind up building the cloud that they use to serve AI in an architecture that is similar to the architecture that we built. And to give you an idea of how unique the architecture is, the way our relationship with Jensen began is, we went over there and we sat in their spaceship office, whatever they call it, and they just kind of brought in, they wanted to know what we were up to, and so they brought in like junior level people, and then they just kind of kept bringing in more and more senior level people, and we topped out at like Jay Purry, who's sort of the COO, and Ian Buck, who is one of the guys who kind of wrote CUDA, the CTO kind of, and that was it. We went home and we were just like, that was weird, and month goes by, we didn't hear anything, and then we get a call from our representative, and he says, Jensen wants you on the phone in 15 minutes, which is like a perfectly Jensen thing, right? Like no time to prepare. You're just like, standing there. This is like, your nightmare of, waking up naked in the middle of a classroom or something, right? Like it's just like, you're just he doesn't want any packaging. And so 15 minutes, we get on the phone with him, and it was supposed to be a half-hour call, and he spent 45 minutes bearing down on Brian on the architecture. Why are you building it this way? How does that benefit my clients? How is that going to make the infrastructure work better? Why didn't you go this way? Why didn't you do that? It was unbelievable. Like his mastery of the concepts were incredible. And then like Eye of Sauron kind of moment here, he just turns to me, and I did not say a word in the technical discussion. There was no reason to expose myself to that. And he just turned to me, and then for 45 minutes just ripped into me. How are you going to raise the money? Why do you think you can finance this? How do you manage credit for startups? How do you do this? How do you do that? Are you going to be able to expand? How are you going to get the data centers to give you capacity when you have no credit?
When was that?
That was 2.5 years ago. I don't know. I suffer from time blindness to begin with, and things have been moving pretty fast. So, yeah, it was when the way that the call ended, and so there was 5 of us actually on the call. The sales guy, who I'm pretty sure was hiding under his desk the entire time, and then myself and Brian, who was my partner, one of the 3 founders, and Jay Purry and Jensen. And at the end of that hour and a half call, he just turned to Jay and said, tell Vishal we're going to invest in these guys. These guys are building the cloud the way I need it to be built. This is the vision of how it's supposed to work. And so like the technical differentiation was enormous, right? Like that was the first place we started. The physical ability to deliver infrastructure, this stuff is super physical. Like you got to build a data center, you got to deal with the cooling, you got to deal with an untold amount of power moving through these systems, and to build an organization that's capable of doing that at velocity and at scale. And those are 2 concepts that I hold the company to at all times, right? Scale decommoditizes compute, right? Getting another GPU doesn't help anybody. Building a cluster that's large enough to train the most important models in the world is no longer a commodity. That is a solution. And then the third area that we focus on is finance, right? And we have been so incredibly, we have been just the tip of the spear thinking about how you go about building a company like this. How do you access the capital markets? And I always joke. I was like, when we started this business, you go out to Silicon Valley and you go out there and you say, I'm going to do this, this, and this. And first they look at you like you're crazy because who takes on the hyperscalers? And then they look at you like, and even if it was a good idea, we've been investing in software and that's not really capital intensive. And that's how we've made the last $1 trillion. So we're not investing in you. And that was disheartening. But to build infrastructure, whether it's the railroads, or the power grid, or power generation, or fuel exploration, or whatever infrastructure you want, at the end of the day, it doesn't happen in the equity markets. And we understood that. Our project finance DNA understood that. And what we did is we looked at the way, we plugged into both markets, right? In West Coast, let's go change the world, and finally got some traction there. And then East Coast capital, which I always say has only one rule, which is do not lose my fucking money. That's it, right? That's the only rule that they play by. And
That's the scientific term.
that is the side. There may be more eloquent ways, but there's certainly not more accurate ways. Like on the finance side, we have been pushing that forward, and even through the IPO, which we IPO'd 3 days before Liberation Day into the tariffs under the direct advice from the investment bankers. You cannot do this. You cannot do this. You cannot do this. To which I responded, that's cool. Why don't you guys step out? You got 20 minutes. Come back in with a better answer because we're going public tomorrow. And I believed fundamentally that like the bankers worrying about their franchise, worrying about the capital, like none of that mattered. What mattered was us becoming a public company, because this company is the definition of what needs to be in the public market. It needs to be able to access the most inexpensive, largest, deepest pools of capital to build infrastructure on a planetary scale. And they didn't understand that.
Let me ask you a question about that. So we are now sort of we're finishing a 3 to 5 year period of massive build out. And you and I were chatting a little bit before we started, and we're talking about training models, inference, and how these things are actually changing. What do you see over the next 3 to 5 years? And we'll ping pong a little bit.
Most important trend, and I would argue maybe the most important trend right now in the world, is the adoption of inference. Inference is the monetization of artificial intelligence. It's the translation of all of this investment into economic return. It is efficiency, it's deflationary, it is where I go to understand that the investments that are flowing into this market are not insane, right? Because when you see companies using the models to solve real economic problems that will generate massive productivity gains, like that's why this works. And so if you don't see inference, that's bad. If you do see inference and you see it accelerating and you see it broadening in its use cases, that is the primary indication of where artificial intelligence will be over the next 5 to 7 years.
Also becoming more cost and energy efficient.
Yeah, so
which is important.
Yeah, so the strides that have been made, like we think about sustainability in two ways, right? We think about sustainability from the perspective of sustainability is near and dear to my heart. It's where I started my career. It's what I was focused on. I thought it was important then. I think it's important now. We are seeing unbelievable improvements in the efficiency from the technology, from a computational power, right? It is faster, it's more energy efficient. The cooling is moved from air to liquid, which has caused like a 60% decrease in energy. Like the strides that are being made are phenomenal. They truly are. And that's one piece of it. Yet the total energy being consumed is obviously roofing. And we think about that in as holistically a way as possible, because this infrastructure, the data centers that we're building, the energy that's being provided to them, that's not a one-term or two-term presidential problem. This is a you're making investments in infrastructure that will survive for 20, 40 years. And the question, depending upon which piece of it you're talking about, and you need to really think about that from a environmental perspective and a sustainability perspective and a financial viability perspective, because as the issues of sustainability become more important over time or less important over time, that will impact the viability of different pieces of the very, very, very expensive infrastructure building. And so, we just announced in the UK another £1.5 billion investment into the data centers up in Scotland, which is 100% renewable. We're definitely incredibly focused on it to the extent that the grids can handle it.
Can you mentioned UK and then you mentioned Scotland. Can you tell us a little bit about your geographic play?
Yeah. So going back to my background again, right? I ran NatSource Asset Management, probably the largest pool of private capital focused on climate change in the early 2000s. Sometimes I say things that may not be exactly correct, but they're certainly directionally correct. Let's take the win. And so when I was doing that, I was working on projects in China. And that was, you go to those big chemical plants and you can make unbelievable impact on emissions by tackling some of those really, really large facilities with catalysts or incinerators or whatever. And I am going to tie this back to our geographic. So let me go the other way. We're largely in the U.S., right? We've got 32, 35 data centers in the U.S., expanding very, very rapidly here. We are expanding in the U.K., Spain, up through the Nordics to support Northern Europe, Germany, that kind of stuff. We have aspirations of building infrastructure globally, which means that we will have to make real inroads in the Middle East and throughout Asia, which is multiple markets, obviously, and as well as South America. And so, that's the plan, that's the board. However, I don't feel like I have the skill set to single-handedly build that. And so to continue to expand into the Middle East, into Asia, into South America, that's going to be through finding the right partners and working with them as we continue to build and expand. We've done that to certain extents on certain skill sets, even within the US. So we own a piece of a data center provider where we're building. I don't know how to build these things, so let's go find somebody that we can work with that can help us kind of absorb those skill sets and kind of allow us to do what we do really well. And so that's the broader strategy. So we're across the U.S., Canada. We're really accelerating with